let me record now because I didn't do it earlier. My bad. All right. Okay, so we just did a problem through from one of the homework problems. Let me kind of keep going, and I'll tell you what, guys. Let's start. Let's start with this one. Okay. And so one thing I want to mention about this problem here. This problem is slightly different. The part that's different is that we have that minus pi over 4 on the inside, right? Okay, so we're going to do the parts that we already know how to do, right? And the parts that we already know how to do, we know how to find the amplitude, and we know how to find the period, right? All right, anybody know what the amplitude is here? 3. Okay, now let's find the period. Remember how we're going to find the period? We're going to take something and divide it by something else. 2 pi divided by 2. Period is going to be pi, okay? All right, guys, we're going to talk about the phase shift. We'll talk about that in a second, okay? Just like we've been doing all the other problems, we're going to take what we had on the inside, which was that 2x minus, what was it, pi over 4? Yeah. Minus pi over 4. And do you remember we were doing this inequality here? So we're going to do that, okay? So I'm not doing anything any different. We're taking what we had inside those parentheses and we're putting that between those two bounds. First question, how do I get rid of that minus pi over 4? We got to add it, right? If it's being subtracted, we got to add it. We'll get to the reciprocal part in a second. Okay. So 0 on pi over 4 is still pi over 4. Okay. And remember, we're adding here, right? So guys, let's do this piece over here on the side. Think about it like this, 2 pi over 1 plus pi over 4. Okay, what's my common denominator here? Negative 4. So we're going to multiply this guy by 4 and this guy by 4. So that's going to give me an 8 pi over 4 plus pi over 4. So that should end up being 9 pi over 4. Okay, last question. How do I get rid of this 2 right here? Reciprocal, right? 1/2. Guys, I know we could say divided by 2. The reason why I do the reciprocal is because I already have fractions. Okay. So look, isn't this going to give me pi over 8? And this is going to give me 9 pi over 8? Okay. So when we were doing this a while ago, remember we said we just found the first value and we just found the last value. We still got to find what? The 3 in the middle? Okay. So just like we did before, y'all, we're going to write 2x minus pi over 4 equals, remember the first one was pi over 2. 2x minus pi over 4 equals pi. And 2x minus pi over 4 equals 3 pi over 2. Perfect. Okay. I'm just setting up the 3 equations that I need to solve, okay? Now, let's solve this one. Excuse me. So I'm going to add pi over 4 to both sides. Okay, so that's going to leave me with 2x equals. Now, I need to get a common denominator between 2 and 4. What is it? So we're going to multiply this guy by 2 and this guy by 2. So that's going to leave me with a 2 pi over 4 plus another pi over 4. That's going to give me 3 pi over 4. You remember how we said we're getting rid of the 2? Reciprocal, 1/2. Very good. Okay, boom. We found the first of the 3 values that we got to do. We're going to do this 2 more times. Okay? All right. So guys, if you want to, could I do this? for my common denominator? Does that make sense so far? All right. So 2x equals 4 pi plus another pi? 5 pi over 4. Good. And then we're going to do the reciprocal. 5 pi over 8. They're going to be, they'll be that same kind of format, right? Let me show you this. This one is 3 pi over 8, right? This one is 5 pi over 8. What do you think the next one could be? Look at a pattern. So look, 3, 5. How much am I going up by? 2. What do you think the next one would be? 7 pi over 8? Let's double check. Let's make sure it is. Now we have 2x equals, remember I'm going to multiply this guy by 2 and this guy by 2. So that's 6 pi over 4 plus another pi over 4. That's going to give me 2x equals 7 pi over 4. And then, excuse me, we do our 1/2, and there you go. 7 pi over 8, right? So you see the pattern, right? Okay. So let's take a look here. All right. I'm going to start making a table, and I'll zoom back in a second, guys. Remember, here's the first, second, third, fourth, and the fifth. So I'm going to go like this: pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8, right? Okay, let's zoom in a little bit. There we go. And then, what did we have on the inside of our parentheses? We had all of this business. So I'm going to go 2x minus pi over 4, and these are going to be our standard values. Okay. And then we're going to say, what is the sign of those values? Sign of 0 was 0, 1. That's why I put that right there, right? So we always have it as a reference, right? And then what's the only thing we're going to put in front? A 3. So all we're going to do now, y'all, is take those same numbers and multiply them by 3. So this is 0, 3, 0, negative 3, 0, right? So now remember, when I'm going to come back to doing my graph, the numbers that I'm really interested in using are those and those, right? Okay, so at pi over 8, we should be at 0. So look, if I zoom in here, at pi over 8, we're going to be at 0. At 3 pi over 8, we're going to be at 3. 3 pi over 8, we're going to be at 3. At 5 pi over 8, we were back at 0. 7 pi over 8, we were at negative 3. And then 9 pi over 8, we're back at 0. Is that working? We're okay so far? Okay, so we got to talk about what's the phase shift, okay? Because that was the one part we haven't answered yet. So look, I'm going to come back over here and look what it tells me right here. There we go. The phase shift is the left endpoint. What was that first value that we had right there? And we can look at the table because it'll pi over 8. There's my phase shift. So phase shift. Oops. Phase shift is pi over 8. And we got it. Again, guys, takes a little time to do, right? It takes a little time to do, but I'm hoping that as you go through and you can see the format that I'm trying to follow, it's going to work every single time. Okay, it's going to work every single time. All right, so I'll tell you what, let's kind of scroll a little bit. So this one is kind of like the one we just did. So I'm going to kind of skip over that one because it's the same type of problem. But I do want us to do this one here. Okay, I want us to go through this one, and I want you to notice now there's an extra change. Now we have not only that 2 cosine 4x minus 3 pi, we have a plus 5 on that side. So I'm going to show you how we're going to do these, okay? The process is going to be the same. So look, amplitude, period, phase shift, vertical shift. We already know how to find amplitude. What's our amplitude here? 2. Okay. Period. 2 pi over what? Over 4, right? It's always the number in front of the x, which is pi over 2. Yes. So, yeah. Okay. Yes, right here, my period is always going to be 2 pi over b, and notice where the b is. It's that number. Excellent question. Good. Perfect. Okay, guys, remember how we set it up earlier? The first thing we would write is we'd write 0 is less than or equal to, and we're going to take this part right here. There you go. And that's going to be less than or equal to 2 pi. Okay. And now we're going to solve that inequality. So we're going to add 3 pi all the way across. Good. Okay. So 3 pi less than or equal to 4x less than or equal to, what is that, 5 pi? Okay. And now we're going to divide everything by 4. Okay. So this is going to be 3 pi over 4 is less than or equal to x, which is less than or equal to 5 pi over 4. Okay. All right. Guys, do you remember what we said, which one the phase shift was? The phase shift was always that point right there. Okay, so it's going to be, in this case, it's going to be 3 pi over 4. And I want you to notice what they put here. It says the phase shift is c over b. So here's my c, here's my b. If you look at this problem right here, y'all, what's our number c in this part? But look, see how it has a minus, and this already has a minus 2, right? So what would the c part be? Positive what though? 3 pi over b, which was 4, and that's exactly what we have right there. Okay, so you can do it either way, right? It's either the endpoint here, or you can use that little formula. I'm sorry? Because it's only, because the phase shift is only the c over b, and remember the b is just the number in front of the x. It's just the coefficient of the x. Good question. All right. So guys, just like we did before, remember, this here is the first point. This is my last point. I still got to find my 3 in the middle, right? So we're going to do it like this. We're going to say 4x minus 3 pi equals pi over 2. 4x minus 3 pi equals pi. And one more. 4x minus 3 pi equals, anybody remember? 3 pi over 2, right? Okay. Alrighty, let's do it. First thing, let me add 3 pi to both sides. So those are going to go away. This is going to leave me with 4x equals. Guys, I'm going to think of that as 3 pi over 1. Between 2 and 1, what is my common denominator? So let's multiply this one by 2 and that one by 2. That's going to leave me with pi over 2 plus 6 pi over 2, which is 4x equals, very good, 7 pi over 2. How did we say we're going to get rid of our fourth? Reciprocal, perfect. 1 over 4, 1 over 4. Isn't this now 7 pi over 8? We're doing okay so far? So far, so good? Okay. Let's do the same thing with this one here. We're going to add 3 pi. This one's probably going to be a little bit easier to do, right? Isn't that 4 pi? Divided by 4, divided by 4. What do we get for this part? This pi? Does that make sense? Okay, just check with me, guys. All right. So remember, same thing here, y'all. We're going to add 3 pi. So I'm going to add 3 pi. I'll think of that as 3 pi over 1. Those are going to cancel. Okay, so we got to get a common denominator. And again, between 2 and 1, it's going to be 2. So this is 3 pi plus 3 times 2 is 6 pi over 2. This is over 2. So that should give me what? 9 pi over 2? And then multiply by the reciprocal 1/4. And we end up with what? 9 pi over 8? We good so far? All right. So guys, we're going to make our table, right? We're going to go like this. X All right, so we got 3 pi over 4 for the first one, and 7 pi over 8. What was the other one? Pi, 9 pi over 8, and 5 pi over 8. Okay. All right, so now I'm going to put this part here in the middle. 4x minus 3 pi. Remember, these are my standard values, right? My 0, pi over 2, pi, 3 pi over 2, and 2 pi. There we go. And then we're taking the cosine of those values. Okay. Cosine of 0 was 1, 0, negative 1, 0, back to 1. Okay, what do we have in front of it now? A 2. So guys, I'm just going to put a 2 here instead of writing the whole thing out, okay? But you know what I'm doing, right? I'm just multiplying everything by 2. So 2 times 0 is 2. I'm sorry, 2 times 1 is 2, sorry. 2 times 0? Very good. Back to 2. Okay. Now, we're almost done. What do we have at the very end here? Okay. All we're going to do now, y'all, is add 5. So we're going to take each of these numbers that we have here, and we're going to add 5 to each of them. 2 plus 5? 7. 0 plus 5? 5. Negative 2 plus 5? 0 plus 5? 2 plus 5? Boom. Okay. I know. I lost you a long time ago? Okay. So you got to let me know as I'm going through, okay? Just so that I don't lose you, okay? Let me ask you a question. Are you good? Are you good how we got our values here? remember the first point, the second point, we said each of those values, you know what I'm talking about? Okay. And then you're okay how I put my standard values in here. Like so what do I have here? 0, pi over 2, pi, 3 pi over 2, 2 pi, right? Okay, now what function am I using? We're using the cosine, right? So what's the cosine of those values? 1, 0, negative 1, 0, 1, right? What did we do now? We multiplied each of those numbers by 2. That's how we came up with those numbers there. What was the last thing we did? We added 5. So all it is, I took this row now, and I just added 5 to each of them. Okay, so let me show you what we're going to do now, y'all. We're going to draw our picture. Okay. Look at what we're starting. We're starting at 3 pi over 4. So I'm just going to do this. 3 pi over 4, 7 pi over 8, pi, 9 pi over 8, and it was 5 pi over 4. I don't know why I put it in. And 5 pi over 4. Okay. So there's that part. Okay. And now all we're going to do is we're going to start plotting these numbers here. So I'm going to go up 1, oops, let me get a little bit of a back here. 1, 2, 3, 4, 5, 6, 7. So we start over here at 7, and we come down to 5, and we come down to 3, we come back up to 5, we go back up to 7, and there's my picture. Okay. All right, guys, before I go on, remember a couple of things we talked about? We talked about the amplitude, right? And we already said what the amplitude was, right? What was the amplitude right here? 2, right? In terms of the picture, I told y'all before, there's something called the midline. This is my midline right here, right? If this is 1, 2, 3, 4, 5, 6, 7, the amplitude measures how far it is from here to here, or from here to here, or from here to here. Everybody agree that's a distance of 2? Because I'm either going from 5 to 7, or I'm going from 3 to 5, but the distance there is 2, right? Okay. Our period, we said, was the length it takes us to make a complete cycle. And we found it by taking 2 pi and dividing it by 4. I know it's real small because I'm zooming out, but it's right there, right? So there's my period. We found our phase shift because we said our phase shift was going to be the left endpoint, which was this one right here. There's my phase shift, right? Okay. Now, there's something called the vertical shift. The vertical shift is the number that's D, the letter D in our problem. What is the letter D in our problem here? There you go. Okay. So I'm just going to write it again. Amplitude is 2. Period was pi over 2. Phase shift was 3 pi over 4. And what was the other one called? Vertical shift? Vertical shift was and wait, what's about that? The one thing that I want to try to emphasize as much as I can is that the process is the same every single time. You take what you have inside. What I mean by inside is friction, and you set up that inequality. So 0 less than or equal to whatever you have on the inside, less than or equal to 2 pi. Once you find those values, that's your first point and your end point. This one here is going to be your phase shift, right? Then you take whatever you have on the inside, and you set it equal to pi over 2, pi, 3 pi over 2, you can find your other 3 values. And then from there, all you're doing is building up on that. right? But the process is going to be the same every single time. Okay, every single time. Question? No. Okay. I didn't know if you were raising your hand. All right. So guys, I'm going to kind of skip over number 7 simply because number 7 is the same type of problem that you just did. Okay. But I do want to go through this one here. Okay. So we want to see if we can find out some pieces of information. All right. So it says write a function of the form f of x equals cosine a cosine dx minus c for the given graph. All right. So guys, when I'm going to do this problem here, remember one of the things we're looking for the amplitude. Remember what the amplitude measures? From the middle to the top or from the middle down, right? So let me zoom in. From here to here, how much would that be? 2. Okay, so we found our A value. Our A value is 2, right? Okay. Now the other thing we need to do is we need to find the period. Now, guys, they're asking me to use cosine. Let me ask you a question. If I did this here and did this here, and I told you guys, do me a favor. Pretend this piece wasn't here. Does that look like a cosine graph to you guys? Right? Because the cosine does this, it's kind of like a bowl, right? Or the sine does more like that. Does that make any sense? Okay. So the cosine does this, right? Would you agree with me from here to here would be one complete period because you start and end at the same piece? So what I need to do is I need to figure out how far is it from here to here. How would I do it? Yeah, so we're going to go 7 pi over 3 minus pi over 3, right? So think about it this way. Forget the pi. If this was 1, 5, whatever, and they were just regular whole pretty numbers, you would subtract that. We're going to do that here. So we're going to take 7 pi over 3 minus which one? Pi over 3. You might be, I don't know. We're going to figure it out right now. 7 pi over 3 minus pi over 3, 6 pi over 3, which is 2 pi. Perfect. Okay. All right, guys, remember, so we already know what the A value is. We need to find the B value, right? So remember the way we find the B value? Didn't we say that the period is always going to be 2 pi over whatever that number B is? And in this case, the period was 2 pi. So what would my number B have to be in order for these two things to be the same? So look, let's do it like this. Let's think of this as over 1, and let's cross multiply. So 2 pi B equals 2 pi times 1 is still 2 pi. So if we divide both sides by 2 pi, what would my number be? There we go. Boom. We got that part right. Okay. All right. So we already found the A number. We already found the B number. The only number we still need to find, y'all, is the C. So if you remember, the C is this starting point right here. So if I erase it so you can see a little bit better, what would you say our C number would be? What would you say our C number would be? This one? Pi over 3. It's going to be that starting point. So look, if I know what C is, and I know what A is, and I know what B is, could we write out our equation in this form? What are we going to put first? Y equals 2 cosine. What did we say our number B was? 1. So you don't got to put a 1. You can just put an X. Minus, what's the number C? Yes. but remember, this is my, because I'm thinking about this as a cosine. My cosine, in terms of a cosine, my cosine would, this is what my cosine graph looks like, right? So my cosine would really be starting right here. This, remember, the graph keeps going on and on and on and on and on forever, right? It kind of does that number. So I'm not really considering that my starting point. I'm considering my starting point in terms of the cosine. The cosine should be starting, you know, you see what I'm saying? Something like that. So that's the reason why I'm doing it that way. Now, I would have used that number if it would have said, can you use a sine function? Because remember, the sine function does this. Does that make sense? So we could have rewritten this problem using sine, and we would have been using that negative pi over 6 type, right? I'm sorry? This way or this way? And so guys, when I put those lines on that way, I put those lines because that's what my cosine graph looks like. Does that make sense? So I'm not really paying attention to anything on the outside of it. And the reason why I'm doing that is because it said, can I do this using a cosine function? So I have to remember what's the basic shape of my cosine function, right? So the cosine function guys looks kind of like a bowl, and then the sine kind of does look like an S, right? But remember, if you extend that graph out, like if you graph it over more periods, those two graphs look exactly the same, right? They're just one's like this, and the other one's just shifted a little bit further, right? So guys, do y'all have at your house, your CS house, your grandma's house, your grandma, do you have something like this? But it does this number, right? This is exactly what the sine and the cosine function do. Think about it this way. Suppose this, think about my cosine function. This is, cosine is 0. Cosine of 0 is 1, right? Then we come over here to pi over 2. What's cosine of pi over 2? 0, right? Then we come this way. Cosine of pi. What number is it? What's cosine of pi? Negative 1. Then we go to cosine of 3 pi over 2. We're back at 0. Then we come to cosine of 2 pi. We're back at, that's what they call those sounds, oscillating sounds. These functions are called oscillatory functions. It's the same name, right? Roberto, Robert. Tomas, Tommy. That kind of thing, right? It's the same concept. Okay. All right. I don't want you all to think I'm just hogging up all the air, so I'm going to do that. All right. So guys, I got one last problem here that I want us to go through. The idea behind this problem here is we're going to see, just given some basic information, can we come up with an equation? So look what the problem says. It says an adult human rests at rest, inhales and exhales approximately 500 milliliters of air. They're called tidal volume in approximately 5 seconds. So what does that mean? How long should that have taken me according to this problem? 5 seconds. That 5 seconds, that's the inhale and the exhale. What is that distance called? And we do both. What do we call that? From the start to the finish. What are we going to call that in terms of our graph? Okay. So we know the period is how long? How long does it take me to do this? 5 seconds, right? Okay. So look, I'm just gonna, before I read anything else, look at part C. What does part C say? What is the period of a complete cycle? Boom, 5 seconds. Okay. It says, however, at the end of each exhalation, the lungs still contain a volume of air called the functional residual capacity, which is approximately 2,000 milliliters. Okay, how much volume of air is in the lungs after inhalation? So I've already exhaled. I still have 2,000 milliliters. Now I'm going to inhale. How much air am I inhaling? 500. So how much do I have when I inhale? 2,500. Okay, so right here, we're going to put now 2,500. How much volume of air do we have after we breathe it out? 2,000. Before I go on, are we okay with why it's 2,000? Because it tells me right here, even after we have exhaled, we still have 2,000, right? Okay. What is the highest point of my graph? 2,500. What's the lowest part of my graph? 2,000. Okay, so guys, so we'll get to that vertical shift right now in a second, because we're going to be doing this business here, right? And we're going to use kind of a cosine function, so I'm going to do something like this, right? And actually, let me make that better, because that doesn't look like what it should look like. It should look something like this. So we said the lowest number was 2,000, and the highest number was 2,500, so my graph should look something like that, okay? Now, one thing we need to figure out is we need to find the amplitude. Do you remember what we said the amplitude was? When we had that line that went in the middle, the amplitude went from here to here, or from here to here. What would you say our amplitude would be? 250? Right? If from the highest point to the lowest point, if it's a distance of 500, then from the middle to the top, wouldn't that have to be 250? Or from the middle to the bottom, wouldn't that have to be 250? All right, so we know that our A is 250. So we're going to start writing this function out. V of t equals 250 cosine of. Now, we got to find that B number, okay? I'm going to show you how we're going to find the B number. Guys, I'm going to slide this over here. Okay, we said that our period was 5 seconds. And the period is going to be 2 pi over whatever my number B is. So all I'm going to do here, y'all, I'm going to think of this over 1, and I'm going to do a little cross multiply. So 1 times 2 pi is 2 pi. 5 times b is a 5b. Let's divide both sides by 5, and we get b being equal to, what is that, 2 pi over 5? Okay. So I'm going to come back over here, and I'm going to put 2 pi over 5 with a t plus, now, the second thing is we're going to put that vertical, that phase shift, right? That vertical shift. Now, guys, that vertical shift is in fact my midline. If this number here is 2,000, and if this number here is 2,500, what would be the number right in the middle? 2,250? Does that make sense? How we're able to figure that out? You doing okay so far? Yeah? Okay, just checking with y'all. All right, what is the average amount of air in the lungs during one breathing cycle? So the average amount, guys, is that midline, okay? Because think about it, the midline is kind of like your middle, right? So what's the average amount of air during one breathing cycle? What do we say our midline was? 2,250, and it's going to be in mL, right? Because that's what they're giving it for. All right, now I'm just going to zoom in a little bit so you can see a little bit better. Okay, during hyperventilation, breathing is more rapid with deep inhalations and exhalations. What parts of the equation can part B change? So once you look at the equation of part B, this equation, okay? So if we start to hyperventilate, that means that our breathing becomes faster or slower? Faster. You look at the period measure, the period measure is how long it takes to do us. So the period is going to change, right? Because I'm not going to go, that kind of thing, right? So the period is going to change. What value is the period here? What value affects the period in these letters A, B, and D? B. B is going to change, right? When you hyperventilate, it also says that we're not only more rapid, we have deeper inhalation, right? So what else is going to change? right? So the B is going to change, the period, and those ones. Those are going to change, right? Does that make sense on how you're able to figure it out? So guys, one thing that I had to know when doing this kind of problem was, how does my graph compare to the information I have, right? So they told me baseline, after I get hit, I'm still going to have 2,000 milliliters of oxygen or air in my lungs. That's all hey, that's my diet. And when I inhale, I take it like totally, that's an extra 500. Okay, that's going to be my top, my maximum, right? So if I know my max and I know my min, boom, I can find my midline. That's why I know my midline. Now I know that midline, then I can find my altitude. The fact that they told us that the length of time it takes me to inhale and exhale is 5 seconds, that can be my altitude. Does that make any sense? Okay. Guys, the one thing I'm trying to do is when I'm making these notes or I'm editing these notes, I'm basing these notes based on the homework problems that you guys have. So every problem that you're going to see in the homework for 4.5 is coming directly from here. Does that make sense? So when you get to your homework in 4.5, I don't think there's any problems. I don't think there's any, but I'm going to double check. This, we'll do this, you come back here, let's go here, let's go here, and stop. I'm going to check this because I might have put one problem that we didn't. Okay, so I'll tell you what we're going to do. We're going to take this one out. Boom, let him do it. Okay, so look guys, for your homework, you got 11 questions. And every one of these 11 questions is stuff that we did yesterday. That's how I'm trying to base the note in the homework. Whatever I'm covering in the note, you're going to see the exact same type of problems in homework. I mean, the problem might be slightly different, it might have different numbers, but the process is going to be the same. Does that make sense? So guys, one thing I want you to notice for 4.5, the homework is already available today. When is it due? The 15th. When is the 15th? What day next week? Anyway, you got a whole week. For every homework assignment, I'm going to give you an entire week to do each one. So like Monday, when we see each other Monday, I'm going to set up 4.6. It'll be available on Monday, and you'll have until the following Monday to do it. If we do 4.7 that same day, then you'll have an entire week to get them both done. Does that make sense? So whatever we do at class, you'll have a week to get that assignment done. And I'm making them due by 11:59 at night that night. So your homework will either be due Monday night by midnight or Wednesday night by midnight, but you'll have a week to get the problems done. Now, guys, the one thing I'm going to encourage you to do, like I know Thomas says he has to go to work today. What do you look at? Jason 10. So you got to go change, right? You got to go get cleaned up to do your thing. If you guys have time today or tomorrow, do that work. Why? It's go fresh in your head, right? But if you're waiting till Tuesday night or Wednesday night next week, how do I do this? How do I do this? How do I do this? How do this? It's going to be hard because you try to remember some stuff a whole week ago. I give you the week so that you have enough time to get it done. Okay. All right, guys. I hope this was helpful. I hope you all got something out of this, and get your stuff done, guys. Most importantly, be safe. Okay. I hope everybody's doing all right. I hope your families are okay. I hope you haven't had family members get sick and that kind of good stuff. And if you have, I hope.